Okay, so we'll now move to the next part of the lesson, cumulative probability. Okay, so what do you mean by cumulative probability? A cumulative probability function. So for a random variable capital X tells you the sum of all the individual probabilities up to and including the given value of X in the calculation for probability X is less than or equal X. Okay, what do they mean by this? Now, for example, if they ask you to find the probability X is less than or equal to 2, how do you normally find this? Now, in binomial distribution is a discrete distribution. So if you want to find the probability that X is less than or equal to 2, you take the probabilities of what? You start with the probability X value 0, right? You know that these are discrete values. So you go with X value 1 and then you go with X value 2, right? So this is in the previous part, you saw that we got all these probability values individually by using the binomial probability equation, right? So we had the equation. So if you go in this manner, we have to find the probability of each and every one individually and add. But now the thing is, in this section, they're actually giving you a shortcut. They're giving you a shortcut in the sense, now you can see adding, so for example, X less than or equal to, you only have to add 3 probabilities. But what if you have to do the probability X is less than or equal, say you have to find the probability X is less than or equal like 7. So you can see in that case, there are many individual probabilities that you need to add, which is a really tedious task. So in that case, we need an easy way to find the probability. So for that, they are introducing you the cumulative probability function, or they give you the cumulative distribution, the table. So these tables are provided to you in the formula book as well as in the back of your S2 book. Okay, so look, so they have extracted a part of this table here for you to see how these tables actually work. Okay, now look, so this is actually at the back of your S2 book as well, so you can have a look. Okay, so they say here, for the binomial distribution capital X, which follows the binomial distribution, number of trials n, probability of success p, there are tables in the formula book giving the probability. Look, what probability are they giving you in this table? They always give you the probability that the less than or equal probabilities are only given in this table. You can only use this table. The values given in the tables are only given for less than or equal probability. Okay. So for various values of n and p, an extract from the table is shown below. So guys, look at the table that they have given. Now in this table, they have given you a row and they have told you the n value they are using here is 5. N is equal to 5. And can you see that they are giving you different x values? X value 0, 1, 2, 3, and 4 is given to you. Okay, and the probability values, you can see they are giving you various probability values. So they have given you some selected probability values, 0 0.05, 0 0.1, 0 0.15, and so on. Okay, so now let's see how we can actually use this table. Okay, so let me give you a small example to show how this works. Okay, let's consider X has a binomial distribution. Okay, let's say our n is 5. So we have 5 fixed trials. And let's take the probability of success as 0.2. Are you with me? I'm going to consider a binomial distribution with 5 trials and probability of success 0.2. Okay, first let's work on this manually and then let's use the table to see if it works. Okay, I want you all to find the probability X is less than or equal 1. Okay, I want you to do this manually first. How do you find the probability X is less than or equal 1? How do you find the probability X is less than or equal 1? X equals 0 and X equals 1. So let's find this probability manually by using the binomial distribution. You recall this from the previous part, right? If probability, if the variable is equal to X, we write this as NCX p to the power X, 1 minus p to the power n minus X. Do you recall this equation? Okay, shall we use this equation twice to find this? Let's find the value. So when X is 0, the n value is 5, right? 5C0, probability of success. So probability of success is 0.2 to the power X, X is 0 into 1 minus P is 0.8. The probability of failure to the power n minus X, 5 minus 0, that's 5. Guys, do you agree? The next one, when X is 1, it's 5C1, probability of success to the power 1 into probability of failure 0.8 to the power 5 minus 1. That's a 4. Guys, let's type this in the calendar and get the answer. So we get the answer. I think we get quite an exact answer, 0.73728. Guys, do you agree? Okay, 0.73728. So this is the answer you get when you work on it manually. So I think if you correct it to 4dp, 0.7373. Guys, do you agree? If I make it correct to 4dp, it's 0.7373. Okay, now look. Shall we try to find the same answer by using this table? Okay, now let's see how to use the table to find the probability x is less than or equal 1. So guys, what you should do is you should go to the probability table, and here I have a binomial distribution with n value 5. So go to the binomial cumulative distribution table and go to the row where you find n equals to 5. So in your table, you will find that they will give you there are many x values. There are many n values. They give you rows with many n values. You have to choose the row with n value 5. The n value is 5. And what about the simple x value? So you're trying to find the probability x is less than or equal 1. So the x value is 1. Guys, are you with me? So n value is 5 and the x value is 1. Are you with me? So you can take your ruler. You can take your ruler and place it. Can you see? I have kept it on the row where x is equal to 1. Guys, are you with me? And what about the probability value? Probability of success is 0.2. So go to the column, because the columns gives you the probabilities. Can you see 0.2 up here? And then go down to the row. So what's the answer? I think you guys can all clearly see that we get 0.7373. Guys, can you see? So then can you see that you are actually immediately getting the sum of the probabilities here? Okay, so that's why we say this table is giving you the cumulative probabilities, because you can see immediately you get the answer. You don't need to perform any calculation. It immediately gives you the cumulative probability x is less than or equal 1. In the sense, you immediately get the probability of x equals 0 plus x equal 1. Is this clear? Is this clear, guys? So you can see that instead of working manually, now we can use the help of this particular table to calculate these less than or equal probabilities. Is this clear? So guys, I have done both these methods just to show you that now we don't need to go with these long methods anymore. Are you with me? So I just wanted to show you that the long method is there. I just want to show you that we can, instead of going through with all these probabilities and finding manual calculations, we can now actually go with the table as a shortcut. So you don't need to do all of these working. Is this clear? Okay, let's use this table to calculate a few more probabilities before I change the n value. Okay, so using the same distribution, using the binomial distribution, n is 5. Okay, let me change the probability, 0.25. Can you all directly calculate me the probability that x is less than or equal to 3? So what is the probability that x is less than or equal to 3? N value is 5. Probability of success is 0.25. So how do you find the probability? Directly from the table. N value 5. What's the x value? Who is the simple x value? Simple x value is 3. So you'll keep your ruler at the simple x value of 3. Guys, are you with me? So go to the simple x value of 3. And now, who is the probability of success? 0.25. So go to 0.25. And what do you get for the answer here? 0.9844. Guys, can you see? So the answer is 0.9844. Is this clear? So you don't need to show any extra calculation. However, guys, they don't always have to ask you the probability x is less than, right? Less than or equal. So what if they ask you to find the probability x is less than 3? Guys, how do you do this? Okay, what do you mean by x is less than 3? This is a discrete distribution. Okay, this is a discrete distribution. So what do you mean by the probability x is less than 3? X is less than 3 means now are you, obviously you can see the equal mark is not there for 3, which means can we include 3 in this? No, what are the x values we can include? 0, 1 and 2. You can only include those 3, guys. Isn't it? This is a discrete distribution. You can't, you don't have all the x values. You only have those specific x value. So which means, in other words, I can write the probability x is less than 3 in as what? Probability x is less than or equal to 2. Guys, do you agree with this? The probability x is less than 3 can also be written as the probability x is less than or equal to 2. Guys, do you agree? Okay, so now let's use the probability table and get the answer. What's the answer? The probability x is less than or equal to 2. So the n value is 5. I don't need to change the section here. The probability of success is 0.25. And what's the x value now? Who is the simple x value? What is the simple x value I should use now? What's the simple x value we should use? The simple x value is 2. So go to the table and keep your ruler at the row x is simple x is equal to 2. Guys, are you with me? Simple x is equal to 2 and the probability value 0.25. So what's the answer? 0.8965. Guys, are you with me? Is this clear? Let's do another one. So I'll change the variable. Let me change to a different variable. So let's say y. Y follows a binomial distribution. N is 5. Okay, I'm just going with n equal 5 because that's the part of the table that I have. And let's say the probability of success is 0.3. I want you to find the probability that y is y is less than or equal to, okay, let's go with less than. Y is less than 2. Get me the answer. How do you find the probability y is less than 2? Less than 2 means what are the values that we can include? 0 and 1 only. 2 you cannot include. So this I can write this as an inequality as what? Y is less than or equal to 1. So what is y less than or equal to 1? Go to the table. By n value is 5. The probability, the simple x value is 1, right? Are you with me? Then you go to 1 here. And the probability of success 0.3. What's the answer? 0.5282. Guys, can you see what I'm doing over here? Is this part clear? Okay. Okay, so what if I want you to find the probability that y is greater than or equal to 4? How do I find this? So what do you mean by the probability y is greater than or equal to 4? Now you know these tables are designed only to give you what probabilities? Less than or equal. It's only designed to give you less than or equal. So what if I want the other side? What if I want to find the greater than probabilities? How do I do that? Now so greater than, now you should know here, now there are only 5 probability values, right? There are only 5 trials. So which means the probability x is 0, the probability x equal 1, the probability x equal 2, the probability x equal 3, the probability x equal 4, and the probability x equal 5. I can't go for x equal 6, right? We only have 5 trials. So all these probabilities must add up to how much? The total sum of all the probabilities must add up to 1. So if when you say y is greater than or equal 4, it includes what values? Y equals 4 and y equals 5, right? This is the meaning of y greater than or equal 4 because there are only 5 trials. So you can only take the value 4 and 5. Can we go for y equals 6? Y equals 7? You can't because there are only 5 trials. So the maximum value you could possibly get for y is only y equals 5. Do you agree? So and that's why I told you. So if you take the individual y probabilities, actually I should write y here, right? So if you take the individual y probabilities here, these must add up to how much? The individual y probabilities must add up to 1. y0, y2, y3, y equal 4, y equal 5. So when you add these individual probability values, they must add up to 1 because that's the probability distribution. Are you with me? Now, if I want the probability y equal 4 and y equal 5, the thing is I want to do this by using this table. Now, we can, of course, find it manually by using the equation. But how do I use the help of the table? Now, we know the total probability of all of this is equal to 1. So what I could do here is from 1, what should I do? I should remove what? From 1, if I remove the probability, what probabilities do I need to remove? 1 is the total probability. If I want the probability of 4 plus 5, I need to remove what? 0, 1, 2, 3. I need to remove 0, 1, 2, 3. Do you agree? From 1, if I remove the probability 0, 1, 2, 3, I get the probabilities of 4 and 5 remaining. Do you agree? So then what do I do here? I should subtract what probabilities? X0, Y0, Y1, Y2, Y3. In other words, this probability Y is less than or equal 3. Think about this. Okay, so y less than or equal 3. So you can go over here. So the simple x, in other words, in this case, it's the simple y value. Okay, so because I changed the variable to capital Y. Okay, so the y value is 3. So this table gives you the less than or equal probability. The probability and the probability of success is 0.3. And what do we use here? 0.9692. So you will find here 1 minus. This is equal to 1 minus 0.9692. Guys, how much is the answer? 1 minus 0.9692 is 0.0308. Guys, is this clear? Okay, so let's do one more example before I actually move on to the real thing in the table. So I think you get the basic idea of what's going on here, right? Okay, so let's do one more example and then we'll move on. Okay, let me go to this part again. Okay, let's go for another example. Okay, so let's write x follows a binomial distribution. N is 5. Probability of success, let's say it's 0.1. Okay, right. So I want you to find all these probabilities. Part A, get me the probability x is less than or equal to 1. Part B, get me the probability x is less than 2. Part C, I want you to get me the probability x is greater than or equal to 2. Part D, greater than or equal to 3. Greater than or equal to 3. Part D, get me the probability x is greater than 3. Okay, guys, can you work on this? Using this simple table, n value 5, number of trials 5, probability of success 0.1. I want you to find all these probabilities by using this particular table. Okay, let's try to find it. Okay, so to find the probability x is less than or equal 1, you know that this table can be immediately used. Okay, so this table can be immediately used. So let's get it. Okay, so let's get the probability x is less than or equal to 1. So you go to the table. I think we can see we can directly use the table now, right? X is less than or equal 1 is what's the answer? For the probability value 0.1, make sure you choose the correct probability column. The simple x value 0.9185. Guys, do you agree? 0.9185. Okay. How do you get the probability x is less than 2? So the probability x is less than 2 would be what? Now, you know, it's a discrete data distribution. So if they say x less than 2, can we include 2? Can we include 2? No. So what are the x values that we can actually include? We can only include x is 0 and x is 1. So I could write this in other words, x less than 2 can also be written as what? X less than 2 can also be written as x is less than or equal to 1. Guys, this is so important. This is so important. What's the probability x is less than or equal to 1? 0.9185. Okay, so now let's go to the other side. X is greater than or equal to 3. How do I get the probability x is greater than or equal to 3? Greater than or equal to 3 means what do I need to include here? X is greater than or equal to 3 means what do I? How do I get the probability x is greater than or equal to 3? So how do you get the probability x greater than or equal to 3? X greater than or equal to 3. Now you know you have 5 trials. So x greater than or equal 3, they are asking you to include the probability x is 3, x is 4, and x is 5. Are you with me? Now the thing is, this table, however, doesn't work with such problem. I mean, we can't use this table to get the greater than or equal probability. We can only use this to get the cumulative probability, or in other words, the less than or equal probability. So how do I go for that? How do I go for the less than or equal probability? What we do here is x greater than or equal 3. Now you know you need to include 3, 4, and 5, right? So what we do here is from 1, we subtract the probabilities that we do not require. What are the probabilities that we don't require? We don't require 0. X greater than or equal 3 doesn't require the 0. And do we require the x equal 1 probability? Guys, are you with me? We don't require 1. Do we require 2? For x greater than or equal 3, do we require 2? No. So 0, 1, and 2 are the three x values that are not required in x greater than or equal 3. Guys, do you agree with what I said? x0, x1, x2, x3, okay, so x is 4 and x is 5. We know that the total probability must be equal to 1. And what I'm supposed to do is I want to find x greater than or equal 3 means I need to get the probabilities of these 3 guys added. Are you with me? I want to get the probabilities of these 3 guys. Okay, I want to get the probabilities of these 3 guys. Okay, so what I should do here is what? From 1, I should subtract the probability x0, x is 1, and x is 2. Which means what? I should subtract the probability x is less than or equal to 2. Guys, do you agree? So this is equal to 1 minus, what's the probability x is less than or equal to 2? So go to the x equal to the row with x equal to, the probability of success is 0.1. What's the answer? 0. Guys, what's the value here? So x equal to is 0.9914. Can I know the answer? 1 minus 0.9914 is how much? 0.0086 or 8.6 into 10 to the power minus 3. Is this clear? Okay, guys, the next question. X greater than 3. How do you find the probability x is greater than 3? What do you mean by x is greater than 3? What probabilities do we require? X is greater than 3 means I need which probabilities? I need 4 and 5. I need 4 and 5 means, in other words, this is actually the probability x is greater than or equal 4. Do you agree? So if I want the greater than or equal 4 probability, it means I only want 4 and 5. I need to remove what? From 1, I should remove 0, 1, 2, and 3 because I need 4 and 5. So from 1, I should subtract the what probability? X is less than or equal to 4 or 3. X is less than or equal to 3, right? Because I need 4. I need 4 and 5. So if I remove 1 minus x is less than or equal to 3, it removes 0, 1, 2, 3. So 4 and 5 are the only probabilities remaining when I remove the probabilities from 0 to 3. Guys, do you understand? This is crucial. This is really important that you understand this perfectly. Okay, so throughout the entire discrete distribution lesson, we will be using these rules. Okay, so understanding these rules are extremely important. Okay, so how do I get the answer? 1 minus x is less than or equal 3. I'll have to move the row to x is less than or equal 3. The probability of success is 0.1. What's the probability here? 0. What's the probability here? Under the column 0.1, x value is 3. The value is 0.9995. Guys, do you agree? So how much is the answer? 5 into 10 to the power minus 4, 0.0005. 5 into 10 to the power minus 4. Is this clear? Okay. Okay, so based on all those examples we did, you can see I have come up with a set of general rules that you can use when you are going to use cumulative distribution functions. Because in a cumulative distribution function, you can only get the less than or equal probabilities, right? So if they ask you for greater than or equal, or just less than, you need a proper format so that you can always use to get these probabilities. Look. So if you want to find the probability that x is greater than a, so look, I have given you the shortcut. x is greater than a, you can directly find it by getting the probability 1 minus probability x is less than or equal. I think we we just experienced this a moment ago, right? So if you want to find the probability x is greater than 3, can you see we found it by using 1 minus probability x is less than or equal 3? Can you see the example? The probability x greater than 3 is found by 1 minus probability x is less than or equal 3. Do you see? So I have written this in a general rule, which we can always use. And then if you have x is greater than or equal, if the equal mark is there, what do we do? Does this rule make sense? Look. So going back to a rule that we use, when you had x is greater than or equal 3, we did 1 minus x is less than or equal to not 3, right? X is less than or equal to 2, one value lower than that. Guys, can you see? So over here, when they give you ask you to find the probability x is greater than or equal a, that can be found by doing 1 minus the probability x is less than or equal to what? A minus 1, 1 less than this a value. Guys, do you agree? And the next one, the probability x is less than a. How do you find the probability x is less than a? So less than a, guys, look at this. The probability x is less than 2. How did you find the probability x is less than 2? It's equal to the probability x is less than or equal to 1, right? So 1 lesser than this particular value. Can you see? Can you see? So then how does the rule work? X less than a means we don't include a. So then you need to get the probability x is less than or equal a minus 1. Guys, these rules are so important. If you can stick to these rules, you can do most all these sums by actually using the cumulative distribution table, regardless if they give greater than or just the less than. You can always convert it to less than or equal probability. So you can directly use the probability table, the cumulative distribution table. Is this clear? Okay, and also there are some phrases which you must really be familiar with. Okay, so these phrases are often used in the exams and you need to interpret them by using, by writing them in the probability form. So look, so if the phrase says greater than 5, then you write, you can see here we write x greater than 5. And can you see how do you calculate the probability x greater than 5? I think you can use my rules. X greater than 5, a is 5 now. So that's found by 1 minus probability x is less than or equal 5. Guys, can you see that they have used this rule perfectly here? Please check on this. Can you see? Right? No more than 3. So what does the phrase no more than 3 mean? No more than 3 means you cannot exceed 3. 3 is the maximum. So that's why x is less than or equal to 3. No more than 3. It can be less than 3. Do you agree? The maximum you can go is a 3. So x less than or equal 3 to get the probability, do we need to do any conversions? X less than or equal 3 means you can directly you can directly use the table because the probability cumulative table is built for these kinds of probabilities, isn't it? It's built for less than or equal probability. So we don't need to do any conversions. We can directly use the probability table to get the probability x is less than or equal to 3. Do you agree? Yes? Okay, then let's get the next one. At least 7. Guys, what's the meaning of at least 7? Least means that's the at least 7 means 7 is the highest value or the lowest value. At least 7 means least is 7. Lowest value is 7. The x values could be what? Higher than 7. So 7 is the lowest. 7 lowest, so it could be higher than 7. Can you see x is greater than or equal 7? So how do you get the probability x is greater than or equal 7 from the cumulative table? We use the, I think you can see I can go with the second rule. X greater than or equal a is 1 minus probability x is less than or equal a minus 1. So can you see that they have used the rule here? X a is 7. So 1 minus probability x is less than or equal to 7 minus 1. That's how it became a 6, guys. This is clear. This is clear. Okay, next one, fewer than 10. What do you mean by fewer than 10? Fewer than 10 means x is less than 10. Can we put less than or equal to 10 when they say fewer than 10? When they say fewer than 10, you can't take 10. It should be lower than 10. Can you see? The equal mark is not there at 10. So fewer than 10 means I think you can see I'm going with this rule. X is less than a. Can you see? So it's equal to the probability x is less than or equal a minus 1. So fewer than 10 means x is less than or equal 10 minus 1, which is 9. Guys, can you understand? And the next one, at most 8. What do you mean by at most 8? At most 8 means the highest value you can get here is a 8. The highest is 8 and it could be lower than 8. So that's why x is less than or equal to 8. So do I need to do any conversion to get the probability x is less than or equal to 8? Do we need to apply any conversion to work with x less than or equal to 8? No. You know, the table is directly made for these kinds of probabilities, so you can directly go for it. Is this clear? So these three rules are extremely important because you can use these rules to find, to convert all probabilities into less than or equal probabilities. So any probability they give can be converted to less than or equal probabilities by using these rules, because you need those less than or equal probabilities to use the table. Okay. Okay, so now let's practice with these exercises. So let's practice the cumulative distribution. So exercise 1B, question number 1. The random variable capital X follows a binomial distribution with n value 9 and probability of success 0.2. Find the probability X is less than or equal to 4. How do we find the probability less than or equal to 4? So first thing is, let's go for the probability table. Okay, so go to the probability table. Okay, let's go to the probability table and let's write down what are we supposed to do. This is exercise. Yeah, what exercise are we in? Exercise 1B, question number 1. So X follows a binomial distribution. N value is 9, probability of success 0.2. Okay, so part A, what probability are we supposed to find? Find the probability X is less than 4, less than or equal to 4, or less than or equal to 4. Okay, so let's find the probability X is less than or equal to 4. Now you can see in the previous set of questions that I did, you can see all the questions we did was only centered around n equal 5. But now you can see your n value is what? N value is 9. So in that case, you have to go to the appropriate n value first. What's the appropriate n value? N value should be 9. Can you see? So you have to go to the correct column. N value is 9. The simple x value is 4. Okay, guys, can you see? So you need to kind of make it slightly smaller here. Okay, so n value is 9. I'll take the, so we'll have to draw the n value is 9, x value is 4. Guys, can you see? I'm drawing a line over that place. So this is the x value, right? X value is 4. And what's the probability value? The probability value is 0.2. So can you see what's the value we require here? Yeah. So the probability value we require here is 0.9804. Is this clear? .9804. Is this clear? So this is the answer for part A directly. So you have to go to the correct column, the correct n value row, and you have to go to the correct probability column and get the answer. Okay, what's part B? What probability do we have to find in part B? Probability X is less than 3. So guys, I gave you the set of rules. So according to that rule, how do you find the probability X is less than A? How do you find the probability X is less than A? What was the rule I gave you? X is less than A. It's equal to 1 minus, sorry, not 1 minus. We don't need to go for 1 minus. Probability X less than A is equal to probability X is less than or equal A minus 1, right? Guys, do you agree? X is less than A, in other words, is X is less than or equal to A minus 1. So if you want to find the probability A is less than 3, that's equal to probability X is less than what? Probability X is less than or equal to 3 minus 1, which is 2. So guys, let's go to the probability X is less than 2. So how do you get the probability X is less than 2? So guys, draw a line. So with x equal to, can you see I'm drawing a line? The pink color line. Guys, can you see? So x is less than or equal to 2 and take the value. So x less than or equal to what's the value? Under probability 0.2. X less than or equal to the cumulative probability 0.7382. 7382. Guys, can you see how it's done? Part C. You have to find the probability x is. You have to find the probability x is greater than or equal to 2. So how do you get the probability x is greater than or equal to 2? Probability x is greater than or equal to a. How do you get the probability x is greater than or equal to a? That is equal to 1 minus. That's equal to 1 minus probability x is, what is it? X greater than or equal to a is, in other words, equal to 1 minus probability x is less than or equal to a minus 1, right? Guys, do you agree with me? Probability x is greater than or equal to a is equal to 1 minus probability x is less than or equal a minus 1. Okay, is this clear? So x is less than or equal to, how do you fix it? It's equal to 1 minus probability x is less than or equal 2 minus 1. This is clear? So in other words, it's 1 minus probability x is less than or equal 2 minus 1 is 1. So go to the x value 1. So you can see this is the x value I'm underlining in yellow. And the probability is 0.2. So you can highlight it. So what's the value? 0.4362. Guys, can you see? 1 minus 0.4362. How much is it? 55638. Okay, so in part D, you're supposed to find the probability x is equal to 1. Now, wait, how do we get a probability x is equal to 1? You know, this table gives you the less than or equal probabilities, right? You don't get any direct probability. I think other than the very first probability where x is 0, that's the only direct probability you get, right? Where every other probability you get is an addition. So how do you get a single probability? Guys, how do you get a single probability? So if you want to get the probability x equal 1, what you can do here is first, you can get the probability x is less than or equal 1. First, you can get the probability x is less than or equal 1. And then what do we do? From this, we can subtract the probability of what? From this, we can subtract the probability of getting what? X is less than or equal 0. Guys, 0 means now, of course, you know, less than or equal 0 only includes x is 0, right? So x is less than or equal 1 includes what? Probability x is less than or equal 1 includes x is 1 and x is 0. Right, so from this, when they say to subtract x is 0, less than or equal 0, you know that you don't have any negative values here, right? X is the number of trials. The lowest value you could get for the number of trials is 0. So x is less than or equal 0 means x is equal to 0. Guys, do you agree? And can you see what's going on here? Can you see that you can cancel out these two guys and you're remaining with probability x equal 1? So if you want to find the probability x is equal to 1, all you need to do is you have to subtract the probability x is less than or equal 1 from the previous probability. Is this clear? So I'll give you one more general rule in that case. I'll give you one more general rule in that case. So if you want to find the probability x is equal to a, please write down this general rule. If you want to find the probability x is equal to a by using the table, okay, by using the table, what you do is you can do probability x is less than or equal a, and from this you should subtract with whom? You have to subtract with the probability x is less than or equal a minus 1. Can you see? So x less than or equal a, if you subtract with the previous probability, you will get the probability only for x equal a. Okay, so that is if you use the table. Otherwise, of course, if you want to find a single probability value, you can always use what? The binomial probability equation, ncx p to the power x 1 minus p to the power n minus x, because that can be used to find individual probabilities. That can definitely be done. Okay, so let's use that value over here, probability x equal 1. So let's use it. I'll erase this part. So what do we get here? Probability x equal 1. X equal 1 is 0 0.4362 minus x is less than or equal 0. That's the top one, right? 0 0.13. How much is the answer? 0 0.4362 minus 0 0.1342. What do we get for the answer here? 0 0.3020. So that's the answer. Okay. Okay, guys, so let's now move to question number 2. So in question number 2, they say the random variable x follows a binomial distribution with n20 and probability of success 0.35. So they want you to find these probabilities. Okay, so let's see how it's done. The first thing you should do here is you need to find what? Go to the correct binomial table, because the binomial table now has an n value of 20. Are you with me? So go to the binomial table and go to the n value 20. So this is n value 5. We are go to n value 20. So you can see there are several n values, but not all n values are there. Did you notice that? Have they given you all the n values? N12 is there, N15 is there, N20 is there, next N25, N30. So you can see only certain n values are there, right? So basically this binomial table can only be used if these n values are given in the question. Otherwise, you really can't use this. Are you with me? Okay, so let's go to the question. So in question number, in exercise 1B, question number 2. So they say you have a binomial distribution. Okay, so we have a binomial distribution. Let's work it out. Exercise 2B, question number 2. So you have to find x is given. X follows a normal distribution, 20 and 0.35. Okay, right. Okay, so let's get the probabilities. Part A, you are supposed to find the probability. X is less than or equal to 10. Guys, to get the probability x is less than or equal to 10, do we need to do any workings? No, right? Okay, so let me first draw the line. Okay, so I need to consider the probability 0.35, right? Okay, let's draw the line for the probability 0.35. So this is the 0.35 probability line. Okay, so I've taken it over here. Can you see? So I have drawn the line for the probability 0.35 because when I move the screen down, you can't see the probability value again, right? Can you see? So for 0.35, the for n equal 20, I have selected the row, the column for you already. Is this clear? Okay, so to get the x value less than or equal to 10, what do you need to do? So to get the x value less than or equal to 10, let's go to x value 10. Guys, are you with me? And you draw the horizontal line. So what's the probability that we get here? So you can see the probability we get here is 0.9468. Are you with me? So the answer is 0.9468. Guys, what's the part B value? Part B, you should find the probability x is greater than 6. How do you find the probability x is greater than 6? So greater than A probability is what? 1 minus x is greater than means the greater than A is 1 minus x is less than or equal to A directly. We don't need to do A minus 1 here, right? So greater than 6 is less than or equal to 6. So get the answer 1 minus probability x is less than or equal to 6 is. So let's highlight that. So x equals 6 is over here. Guys, can you see it? So the x value that we require is this 0.4166. Guys, can you subtract? 1 minus 0.4166 is 0.5834. 5834. Okay, then part C. Probability x is equal to 5. So I just a moment ago I explained you how this is done. How do you get the probability x is equal to 5? So you could use the binomial equation or you could manipulate the this table values. How do you get it? So I gave you the rule. You can go for the probability x is less than or equal to 5. X is less than or equal to 5. And you subtract with what? X less than or equal 5 includes the probability value 0, 1, 2, 3, 4, 5. From that, you reduce the probability what? Less than or equal to 4. So when you reduce the probability x is less than or equal to 4, you have 0, 1, 2, 3, 4. And then you are only remaining with what? When you remove 0, 1, 2, 3, 4, you will only remain with the x equal 5 probability. Is this clear? So x is equal to 5. Let's get the answer for x equal 5. All right. So for x equal 5, what's the answer? 0.2454, right? Minus x is less than or equal to 4. How do we get that value? 4, you can get it from here, right? So 4. You can see I'm drawing the line for 4 and I'll highlight the value. So that is 0.1182. Guys, can you see? 0.1182. Guys, what's the answer when you subtract 0.1270? Is this clear? Okay, so the last part, you're supposed to find what? The probability x is greater than or equal to 2, less than or equal to 7. Guys, what x values are included here? X like greater than or equal to, less than or equal to 7 includes what? This includes x is 2, x is 3, four, x5 Guys, can you see? So these are the x values I need to include. So how do I get only these x values? But also now you can say, easy to find these values manually by using the probability table, by using the probability binomial equation? Definitely not. So we need to summarize this in a very short way. Can you guys tell me? I'll give you the first clue. First, I will take the probability x is less than or equal 7. So less than or equal 7 includes 0, 1, 2, 3, 4, 5, 6, 7, everything. So from x less than or equal 7, what do I need to remove? You can see that we start with 2, right? So I don't need the x equal 0 probability. I don't need the x equal 1 probability. Do I need the x equal 2? I need x equal 2. So I should remove 0 and 1, which means I should remove the probability what? X is less than or equal to 1. Guys, can you see? So if you want the probabilities between 2 to 7, you take the probability x less than or equal to 7, which includes everything until 7, and you subtract what? X is less than or equal 1, which removes 0 and 1, because I want the things from 2 onwards. Is this clear? All right, so let's get it. Okay, so let's get this one. X is less than or equal 7. That's this one. X is less than or equal 7 is 0.6010. Minus x is less than or equal 1. So what's the probability x is less than or equal to 1? That's this, right? 0.0021. So what's the subtraction? 0.5989. So this is the probability. Is this clear? Okay, so next I'll move on to question number 5. They say 8 fair coins are tossed and the total number of heads showing is recorded. Find the probability of getting no heads. Okay, so guys, we first need to model this question, right? How do you model? So first let's describe, okay, so capital X is the number of heads. Are you with me? Capital X is the number of heads. And they're saying 8 fair coins are tossed, which means we get how many outcomes? If you are tossing 8 fair coins, we get 8 outcomes, isn't it? So X follows a binomial distribution with n being 8. And what's the probability of success? Success is getting a head. Remember now, since we are modeling the number of heads, getting a head is a success. Okay, getting a tail is a failure. That's what we consider here. So getting a head probability is half. I'll write 0.5. Okay, so we need to get the probability of getting no heads. No heads means H is 0. So you can get the probability of 0 heads in 2 ways, either from the table or by using the individual probability equation. So let's go for the probability equation. The table. Let's go for the table. So I have to go to n equal 8, right? So going to n equal 8 and the probability of success was 0.5. Guys, can you see? 0.5, n is 8 and we need x is 0. Guys, can you see? So what do you get there? Yeah, so when I think x is equal to 0, directly it's x equals 0 only has the 0 probability. It's equal 0 probability, right? N is 8, X is 0, and the probability of success 0.5. What's the answer? 0.0039. Can you see? So the answer here, this is equal to 0.0039. Part B, what do you mean by at least two heads? So now I discussed these notations, these wordings with you. So at least two heads means minimum you must have. Actually, this should be X, right? I used X here for heads. So at least two heads means you should have a minimum of two heads, which means X is greater than or equal to 2. So we described these wordings before. So X greater than or 2, in other words, is equal to what? 1 minus probability X is. Now, you know, I can't go for greater than. I should go for less than. X is less than or equal to 2 minus 1. X is greater than or equal A equal 1 minus probability X is less than or equal A minus 1. So X is less than or equal 1. Do you agree? So 1 minus X is less than or equal 1. So let's go for the table. So X is 1. When N is 8, X equal 1. The probability 0. Can you see the pointer? 0.0352, right? What is the answer? 0.9648. Okay. Let's move on to part C. Part C, more heads than tails. So how do you get more heads than tails? Guys, we know X here models the number of heads. So now, you know, if you get X equals 0, then you get 0 heads, which means all the 8 coins gave you tails. X equals 1, what does X equal 1 mean? So from the 8 coins, if you get X equal 1, you get 1 head and 7 tails. Now the thing here is they want you to get more heads than tails. So if you want more heads than tails, what other? Yeah, we need to get at least 5 heads, isn't it? At least 5. So which means X is greater than or equal to 5. Do you agree? 5 heads, 6 heads, 7 heads, 8 heads. So these are all having more heads than tails. Agreed? So this is equal to 1 minus probability X is less than or equal to 4. Let's get the answer. Probability X is less than or equal to 4 from the probability table. What do we get? So X less than or equal to 4 from N equal 8. I think the value here is 0.6367. Guys, do you agree? 0.6367. What's the answer? Zero point 0.3633. So guys, this is the answer. Is this clear? Okay.